Hey everybody, it's nice to see you. I hope that you are doing well. My name is Tim Clicks. I'm on the planet to build a better planet, and let's build a web crawler in Rust. Just so that if you haven't followed the stream before, feel free to introduce yourself in the comments. It's really positive to see a whole bunch of interaction. One of the advantages that you have when you are live is that you can ask questions because it's genuinely live. We're not pre-recorded. I will make mistakes, and so there will be a little bit of that too. We're going to be live coding a whole bunch, and the files will all be available on my GitHub, which is over here at github/timclicks. And in fact, I'll just change that so that you can get the repository to as well. So there we go, /tutorials. The code will be all there. Let's go on with the show. So I'll just hide my name because it's kind of annoying. There is my background. So I'll just bring up the editor. I have created a new project. And so I've run cargo new. And then I just changed the default from hello world to hello internet. And this is probably something that you have seen yourself before. And so what we're trying to do is create a system where we want to download content from a URL. And the natural thing to do if you are new to Rust is probably to say something like, I need async Rust, and I need to go for the sort of the biggest thing out there. And I want to introduce you to a different crate. I'll just check that I'm in the right place. Yes, I am. Cargo add urec. So urec is short for micro rec, or sort of micro requests, and allow me to describe what that is. So I've added a whole bunch of dependencies and so forth as well. And there are lots of features. We're going to we have support for gzip encoding as well as TLS, so that's HTTPS. We also want the, but that's all we need for now. And so I'm going to show you how to download from the web, at least starting out, because it's kind of the first step. Let's go to docs.rs, and we want the urec. We'll just bring the docs up on the side as something that's a little bit helpful for us, and I'll remove that. So here's our code. And we can see here that we'll just pull in the snippet, and there's a little bit of Rust that looks a little bit weird. Immediately, I need to use, actually, I might not even need to do it. We don't really need to set a header. I'll do something with the code though. So print line, and we'll just print out the body to start with, at least. It turns out that we've got a little bit of weirdness going on. So first I need to explain what on earth this return type is. So this result parentheses urec error business, that's a bit odd. And then I need to describe some of the opinions that the library has. I can delete this line though, because that's not really important. And I will try to bring it all into one line. The other thing that I'm going to change is I'm going to go to an actual website. So timclicks.dev. And I'm going to change from HTTP to HTTPS. And hopefully, if I click run, the code will compile and go out to the web and print out some content from my website. Are you with me so far? Hopefully. It's really if you are new to Rust. Okay, cool. So we have actually successfully compiled our very first web request. So that's really quite good that we've been able to do that essentially with no lines. Wow, no real lines ourselves. We just copy and pasted the example from the directory. So I think it might be worthwhile to pause and say, here are some things that we want to explain. So here are some questions to answer. What is this result type, sort of this return type? And I'm just having a little bit of issues with my computer freezing up. And the other thing here is we've got a couple of bits and pieces. I need to deconstruct this method call into a few things. So first of all, I have the type signet or type hinting, which might be obvious or might not. I've got a call, and then I've got a question mark thing, and then I have a into string method, as well as another question mark. So I would like to start with explaining what result error is. Main has some special treatment. If you haven't used Rust before, you might expect that a main function should return something like an integer. That will become the error code the status code that the program itself will return. So something that might look like, so if you've ever used C or probably Java, you'd think of something like this. It's like I return some integer, and 0 indicates success, and any non-zero code indicates something has gone wrong. In the case of Rust, there's a little bit more sophistication. There is some special treatment of this result type, which has on one side some content. And in our case, we say that the empty tuple, or the so-called unit type, is an empty pair of parentheses that contains nothing. Essentially, it represents emptiness and yet also presence of something. It's sort of an acknowledgement that I got to OK. So that's the OK side. So you can think of result OK as being one half of, I keep making typos, which isn't helpful. We've got OK on one side of result, and on the other side of result is error or and that looks like this. If there was a problem, I could unpack any of these calls, and in case the call, we could also conceivably call this, instead of call, we could say this fetch, or go out to the web and make the request. And the question mark has the it has the property where it's actually going to return back errors. So we could let's go and unpack question mark and explain what the error is. So here is my web request. I'm going to create a request, and I want to match on request. If it's okay, then I have then I want to, let's say that I've got some data, and then I want to call into string. Actually, we'll say match request. It's actually if we have some result, response. We received a response, and we actually want to say that we'll convert the response body into a string. I'll leave the second question mark there because it's annoying having to deal with multiple errors at the same time. And the compiler is conveniently telling me that I haven't dealt with one half of the result. So I need to go and do that. So I go on the error side or side. I might have an error type, and the type of the error is going to be a micro-rec error. And however, I'll just allow that to be empty and say that if we receive any error type at all, I would like to crash the program. Oh, maybe that's a little bit unfair. Maybe I'll say standard process exit with code. And the code will be some integer. So this now is looking a little bit more familiar. I could remove, I need to do a little bit more before I can unpack all of so body is, we've kind of done the same thing again, except now I've got this into string, which also has the possibility that might spawn an error. So we could, if we wanted to, be even more verbose and say, okay, well, in that case, I'll match on response. And if, into string. And if it's okay, I have some body. Then I will return body. And if it's an error, and it will say, we just ignore the reasons why, I will return a different error code. Let's say that this is 2. So 2 means that the content was actually unable to be decoded. And now it's much harder to see than the original. So the original code that is provided by the example is commented out, but this is kind of sort of what it unpacks to. So I have a request, and I could even move that over here so that it's that these question marks are essentially a shorthand for taking the error and returning it somehow. Does something slightly different than what I'm describing. What I'm doing right now is actually exiting the program, but the code that we can think of conceptually as the question mark is returning the error back to the call site. There is no call site for main, so we return the error to the operating system essentially. And on the OK side, we propagate up further with our computation. Now I can actually change the return value. Sorry, the return type. Main now implicitly just returns, it actually expects that I'm going to return the so-called unit type, this kind of nothing value, which it will interpret as 0 and return success back to the operating system. So I can run this now. Just checking. Oh, I've received some comments. This is really valuable. Okay. Okay, I've received some very, very positive comments. Your videos are goated for Rust developers, especially for beginners. So keep up the good work. I shall try to keep up the good work. I try to stream around about this time every week, except I shouldn't say every week. That's what it's very aspirational. At this stage, I've only been I'm on a streak of 2. So hopefully you could book this in a calendar, and I will be there next week. But I cannot guarantee that, unfortunately, because I am somewhat awful at keeping to schedule. So what is the question mark? The question mark is what we are unpacking currently. So we are going through the process of explaining that. The question mark takes something which might have an error, this result, and says, what I really care about is the positive, the okay side, the side that I expect. And if I receive the error side, I'm going to return that back to the caller. In the case of main, there is no caller. That's the operating system. And so I'm going to tell the operating system that there was an error, there was a problem there. The question mark does actually do one more thing, which I've been hiding from you, and that it translates between the error type that is generated, let's say that UREC call, and the return type that your function is returning. So if in our case we had this before, a result, we just copied the result directly from this helper question mark. Helper question mark, help example, and we actually have the same error type. But if we wanted to, we could return whatever we wanted. So let's say that we return the standard IO error for whatever reason. We might receive a compile error because, oh no, we won't anymore. We will be for a different reason. So I need to put OK back. And if I uncomment the example code and ask you see that I've got this squiggly red lines underneath my question mark. It says, I can't convert to standard IO error. I've got a UREC error. So what's happening is the question mark operator is doing a translation between what the caller is producing and what we are producing as our return value. And so one of the reasons why your example, one of the reasons why examples will say specifically which error type to return is because the translation can sometimes get muddled. Rust is particularly annoying about the type of error messages. So it's very strongly typed. And so there is and so it will even complain that the error types are the wrong things. So it's like Rust treats the different error types in the same way that you might conceptually treat the difference between a string and an integer. They're completely disjointed, even though they're conceptually in the same thing. Maybe a better analogy would be floating point and integers, for example. Okay, so UREC error is over here. Now we've got another question. Is it okay to return it an error message through the operating system? And that is what I'm doing in this commented out code on lines 21 through 31. I am calling standard process exit with a custom code. For short-lived programs that you write yourself, yeah, do it. Like, this is your code. I mean, are you going to mind that you returned it? The only thing is that if you go around Rust's norms, so for example, if you're immediately exiting, and instead of return, you might find that if you want to integrate with other parts of the ecosystem, especially if you want to produce a library, you should be returning error types. If you're actually writing a library for other people, then you really need to follow the Rust community. If you go and absent-mindedly or slightly deliberately, like essentially exit the program, and you don't provide the ability for users of your library to handle an error, you're really going to irritate a lot of people that end up using your program. But for your stuff, yeah, sure, do whatever feels most natural to you. Remember, when you start with the language, your job is to teach yourself the language. It's not to teach yourself the perfect way to do everything. You don't need perfection to start. Oh, okay. I have a question. What is happening if the page has JavaScript? Well, we're ignoring JavaScript for now. If we needed essentially, if you have dynamic, if you've got any sort of client-side rendering, you actually need to go and have some machinery that will interpret that JavaScript and do all of the work on the client side, fully quote hydrate the page, and then send. That's not this. We can do something like that by embedding we could embed a JavaScript interpreter inside our Rust program, but we don't have the ability to do so right now. Cool. Okay, so let's actually do, now we need to go and find links in here. So we're going to start our crawler, and I'm going to go back to the original shorthand. Conceptually, let's describe our algorithm. We haven't actually done much web crawling. Turns out I actually intended to provide you with a I actually intended to provide you with a tutorial on Rust, so rather than a tutorial on the most performant way to write a web crawler. But so I hope you don't mind. We don't need this anymore. What else have we got? I'm going to ignore a little bit of what it's talking about. Okay, so we're going to start with some list of let mute URLs. This is sometimes known as the frontier. These are and we just create this as a vector, or say vector, and we'll give ourselves some space. So we'll actually we could actually just create an empty one straight away, but we'll say we'll start with 20. I don't know, what's a good number? We're just going to be providing ourselves with the ability to have URLs that we could download. And we're going to, instead of hard coding the URL path, I'm going to show you how to start adding some content to a vector. So I push two URLs. I have this kind of strange type, which is an ampersand str, that will end up hurting us. And so I'm going to immediately confuse you by calling toString. Actually, I might do something else. It depends. I just need to go and check the function arguments. Yeah. But you can see kind of where we're going. We're going to treat the URLs as a stack, and we're going to be putting URLs on the stack and then popping them off once we, in fact, we could even do that now. Since it could be for URL and URLs is going to get very confusing very fast. Rust is, I'm going to show off another thing of Rust, which is that Rust does not like iterator invalidation. Does anyone want to explain, if they would like to, what iterator invalidation is? If no one does so, I will explain that. We want to, so here's our body. It's a string. And now we need to somehow extract new links from the body. In fact, we could even do it from the request, but we because we might want to interpret the header as well. But maybe let's not bother. And new links. And we could URLs push, extend, sorry, new links. We don't have an extract new links function yet, and we need to do some sort of filtering. We need a list of URLs that we've seen. And I'm going to be using set data type, standard collections, and I'm going to be using a hash set. New. And once we've downloaded, we're going to scene add URL. Insert. So we're inserting a new entity into our scene, and then we need to filter new links. So these are actually every single link that we've got that's in the page, or maybe we'll just extract links from body. And we need to say for link in links, if scene contains link, continue, essentially skip. Otherwise, URLs push link. We need to do another thing as well. We can't go off the website. So, so I'm going to just hard code a check. Actually, I'll just put this in here. To do, check that we're on the same domain. So if we don't do this, we're going to start trying to download the entire internet. This is going to go very badly for us. We're not going to have a very good time. It'll be very difficult while we're learning to download the entire internet. How do we do that badly? Will be something like this. It's that we don't have a real URL handling. We don't have the ability to handle URLs properly yet. And so I'm just going to say that if link, so this is actually, I don't have extract links yet. So let's create a stub for that so that the type system knows what we're doing. And I take some string, which is, and I'm just going to, and I return back a vector of strings, which I'm actually not happy with. And I'm going to, there are better ways to do this. And if you know, so here I'm adding the to do macro, which is kind of this really interesting macro, which satisfies the type system. So this return type is exactly what I want. So we see that links is now typed as a vector of strings. However, if you run the code and get to line 3, where to do is, the program crashes because there's nothing to do. Okay, so if scene contains link, then we skip. If link find, and I'm just going to look for the domain name. Templates.dev is some, is none. we couldn't find timclicks.dev. Now we continue as well. Stylistically, I have a preference for avoiding double negatives, and so I prefer not to add exclamation marks in places, and I also prefer to keep conditional checks flat rather than nested. I don't like rightwards drift in the code, but that's only a personal preference. Okay, so now links is good. Sadly, we don't have the ability to extract any links yet. So one way to do this would be to go in and like use regular expressions. And I am going to do something that I do all the time. And I look for Rust CSS selector. Essentially what I want something to do is go and take the HTML that has been returned and has and actually goes and sends something back. But lots of people have already written things that I care about, and here is something useful. So there are two crates. One of them is and like most things in Rust, some crates are kind of not particularly well maintained. I like to go for solutions like this when I'm just kind of throwing things together with the thing that has with the crate that has the most documentation, at least. And so I'm going to pull in scraper. And so how do I do this? Cargo add scraper. So just a very quick point while this is downloading, and the what I'm writing here is not production. We're teaching Rust. I'm unfortunately not going to. This is not a high performance way to do what we're doing. If you want to download, like I said, a single website, it's going to work fine. But if you want to start downloading tens of thousands of URLs at the same time, we're going to need something more sophisticated. But that is beyond the scope of a beginning tutorial. So I'm going to do that horrible thing that content producers say. It's an exercise for the reader. Okay, so we've added our new crate, which is helpful. And so I pull in, I can sort of import, use scraper, this HTML type. And now I'm going to pass the DOM. There's another way of looking at it. Except it's not strictly a DOM from the web point of view. Yo, I've already got a... here is the iterator invalidation that I actually said that I would actually trip me up. It's already breaking, but let's fix this. So actually, I'll show you the error that I'm... we'll just change because the compiler has detected a bug. Just one, you say? No, surely not. The compiler has said, no, while you're going through URLs, you can't touch it. You may not. And so essentially, this loop that starts on line 13 has control over URLs. It has exclusive access. The terminology is kind of difficult to explain. I would like to be more sophisticated, but I don't want to confuse people too much by going down too many rabbit holes. When we go and line 32, we try to push or extend URLs. What we're doing is attempting to have exclusive access in two places. The Rust wording to use is that a for loop naively will create it takes ownership of the collection. When a vector is iterated over, there is a little bit of essentially subtle or hidden control flow. There is a sort of a magic method. That's not quite right. A method into iter is implicitly added to your call. So essentially the for loop is syntactic sugar for something that looks a little bit more like loop, sort of forever. Not quite, but so you actually have an iterator over URLs, and then while you're anyway. I'm just going to add some new syntax. So I'm explaining what for loops do, and it's a while let. And then we could have all the rest of it over down here. Now this is a lot of syntax that you probably can ignore very readily, except for the fact that this into iter method is very important. Into, when it is used in the prefix of a method, will say that I am giving, I have a vector, and I'm going to convert that to an iterator, which is some type that takes ownership of the original collection. From Rust's point of view, the accessing the original variable is no longer valid because I have given ownership to the iterator. At the end of the iteration, the iterator itself will actually have the ability or kind of the license to delete the underlying data. So this is kind of what the for loop is unpacking. So we have this nice shorthand, which is expanded by the compiler into something more complex. And when you begin, you don't really understand kind of the subtleties of what's going on here. One of the problems that we encounter is that we're not allowed to mutate something. we're not given the ability to mutate URLs, even though we've asked for mutable access, because ownership has actually been passed into the for loop. Okay, that was a lot of words. The Sorry, I'm pausing here because I just noticed that Trey is asking about the book, which is shorthand for the Rust programming language. It's I think it's on my bookshelf. I may not have a physical copy, but the and just the process. The question is like sort of an interesting question about learning Rust, and I'll allow other people in the comments to give advice for how to learn the language, particularly if you like building examples. I'm a little bit, I would love to prompt my own book, but I feel as though that would be I'm not sure about the etiquette there. Anyway, we need to figure this out. So we want to go through URLs, treat it as a stack, but also we want to mutate things at the same time. The compiler has recommended that we clone URLs. So if I try build again, it says, whoa, why? It's like, here's a suggestion. Consider cloning the value if the performance cost is acceptable. This is I've highlighted line. Our case, this other error message is different. I will fix that too. It's because my extract links method is not accepting the correct thing, but I can fix that. We need to change the way that we're actually accessing data. So we need to unpack what we're doing. Rust will only provide us with mutable access in one place in one place. There's only one part of the program that is allowed write access to any variable. And there's only one part, and however, we can have multiple readers. So I'll show you another thing that I'm just kind of thinking about now. What if, and the other problem is that I'm highlighting some, we ask for access through or an individual URL for the entire highlighted section. But what if we only need the URL on lines 18 and we only act in lines 36? So what if we changed our access pattern to, instead of asking for access for the entire duration of the iteration, how about we just ask for access and for essentially short fragments of time? So here we go. We say URLs, and we want to actually let URL pop. So we'll treat it like a stack, and we will ask for the most recent thing. I can improve on this, by the way, but for now this will work. So I can actually ask for pop, which will take an item out of URLs, and if there's nothing left, we cannot accidentally work with none and have like a null pointer exception. It won't blow up here. So what I'm going to do is like, if we need to say I'll match on URL, and if there is some content, then in fact I'll match on URL.pop. Now we won't muddle all of our variables. Now we have some URL, and I'll return that. In fact, I could do my processing. Otherwise, none, I'll break. Now, this is quite a messy way forward. I can probably find, well, there is actually some syntax to clean that up. But what we're doing there is we're popping from URLs, and if there is nothing available, we are going to break out of our for loop. So even though it looks like it's an infinite loop, we still have the ability to break. There are some syntactic niceties to clean this up a little bit, but it's so we say that if let and so if our pattern here matches, actually I'll just leave it as it is. It's not as pretty as I would like, but that's okay. We can call the body. We can insert into scene. The extract links method, we still don't know how to do properly, but that's okay. We'll figure that out. On this whole for loop here, I can just comment out. I get an error message, a different error message, which is actually okay. I'm going to do something which will look a little bit odd, but I'm going to ask for read access of the content. People that know me will know that I'm squinting because of This is probably the wrong type to accept, but that's okay. What I'm doing is I have a body. Oh, I knew that. So I have these squiggly lines because I have a linter telling me that I have used I am not using an idiom that it recommends that the Rust community accepts. However, I wanted to show you the long way first. And so unfortunately, the linter here is being slightly unhelpful. I want to demonstrate that we have fixed the code from the point of view of we now can build, can successfully compile the code. Amazing. So the next step is to let's fix this thing. It's going to say, why don't you try with the while loop? And I bet, and so I can actually, with the integration of Rust Analyzer, the extension for VS Code, it can integrate with the Clippy and actually provide the conversion. So what they changed here was the if let. Now, but a subtly different form. So I originally said that if let sum da 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 da. This else. The idea here is if it was anything else, and the only other else would be if it's missing. Now we break. Let does look a bit strange if you're used to thinking of let as a placeholder for a variable or assigning a variable. Strictly speaking, let accepts a pattern which can actually be parameterized by types, for example. So what it's hunting for is a pattern, and I have the sum variant of option. So if I could write the full hand, sorry, I could write this out in full. So it's if you have an option and the variant of option is sum, inside that inside sum is a URL. If that matches, assign the variables to the remaining patterns. If it doesn't, then break. Okay, that was a lot of words again. We have another recommendation that I've done something which is not necessary, and you can see that the linter actually recommends something which I kind of prefer. I prefer not to do, which is that it's saying you should use an exclamation mark. Right, we are getting very close now. HTML. From parse document, and we have our body. What we're hunting for is to find our we're trying to find the href attribute of anchor tags. We could look for other links as well. Actually, let's just say that we have anchors for anchor in CSS select. What do we have with an anchor? We want to access an attribute. In our case, it's an href. And we want to do the same pattern again, is that if we receive some href, which is shorthand for hypertext reference. I don't think I've ever seen anyone refer to href as hypertext reference before. It's like, oh well. They should. It feels like it has more rigor. We need to do something subtle. You see the href has typed ampersand stir, so a string slice. This is a reference to some span of bytes, which is guaranteed to be UTF-8. Whew, that's a lot. We are returning strings with a capital S, which are different. A string slice could be pointing to data that is anywhere, and a string specifically is data that I control, like me, the variable. Let's say I've got here a vector and new, and links needs ownership, needs control over its links or its contents. And so I need to actually links push href to string. This will take whatever I'm pointing to, irrespective of where it is in memory, and then allocate it on the heap, and then pass and give ownership of essentially duplicates whatever it has seen, and now links has now links has exclusive access. We could be a little bit smarter. There are a couple of things we could do. We don't want to actually have multiple. We need a bunch of. We don't want to go and add lots of duplicates to our code. But sorry, we could actually filter duplicates right now, but I'm not going to bother. And scraper. And it's presumably. So, the compiler just complained at me because I said that I wanted to give it an A, and it said, no, I need a selector. And so I just guessed that there would be a selector type inside of the scraper thing, and inside scraper is presumably I wonder if it has from, but I'm going to say parse, and then I'll just say A. And I'm going to do something which I haven't introduced yet, which is unwrap, which will, what is, which will crash the program if I have sent an invalid CSS. However, I know that A is a valid CSS selector, and so it's not going to crash. It does ask for read access, or as here, please borrow. And now we should be good. I'm going to no longer print out the whole body. Instead, I'm going to print out the URL, I think, because, and I'll need to clone it over here. Hopefully I won't crash my own website. So going to the first one. And now we get all of the videos that that I've seen. So we are actually going and downloading a whole bunch of interesting stuff. And with that, I'm actually going to close the stream. So I will pause there for questions, but we have our crawler working. This will go and download as much as it can. And I hope that you are, I'll push the code up, and we will get going. We'll let you have the rest of your day. I really appreciate everyone's support. Thank you so much. Feel free to like hit follow or subscribe or whatever you prefer. And if you have other suggestions for topics, please let me know. Again, I'm going to try to be live this time most weeks. And so please feel free to add that to your calendar. I am Tim Clicks and I'm on the planet to build a better planet. Thanks so much, Rob, it's nice to see you again. And thanks to everyone for your comments and your suggestions. It's been a real pleasure bringing this to you. Hopefully now I can find the right thing, the right button, and I will send you on your way. Take care, everyone. Have a lovely day.